Good morning, chemistry fans. Here we go with another lab day. Once again, brought in my old friend and trusted lab assistant to help us out. Today, we're looking at LeChatelier's principle in equilibrium. We've been learning about reversible reactions. And really the key to that is how you can shift the amount of product or the amount of reactant by putting a stress. If you remember, LeChatelier said if you put a stress on a system in equilibrium, then it will find a way to balance out. It will go out of equilibrium. Either the forward rate or the reaction rate will go faster for a short period of time until it settles into a new equilibrium, but it will go back into equilibrium and relieve the stress. So we have a few things we're doing here with color changes, some concentration, some temperature, kind of stuff to affect the equilibrium. And I'm going to start on part one. And this is working with some iron chloride and potassium thiocyanate. Now you look at the reaction I have there on your lab sheet, and you say, where's the reaction? I see these ions and forming a compound and everything else. It is a double replacement reaction, but what I've done is I've removed what are called the spectator ions and really just kept in there the ones that are being altered, more or less iron thiocyanate or the iron thiocyanate compound, whatever it would be. That's the color changes we're seeing. Anyhow, let's follow this procedure for our first step. And really, all I'm going to do in my first test tube here is I need 2 drops, 1, 2, of the iron chloride, iron 3 chloride. Here's my potassium thiocyanate, 2 drops here, okay, and a 1 and a 2. And you see in the bottom of that test tube, it's a really dark red color. And then I'm going to take and basically fill the tube with distilled water almost all the way, and dilute it out a little bit. And let me take my parafilm and do a little mixing. Okay. And you can see that it turned kind of an orangish color. That's what we were looking for. Okay. Now I'm going to roughly divide it between my test tubes here a little bit. Try and get roughly an even amount in each. That's way too much, but it doesn't matter. We'll kind of split them out between the two. We'll get it all figured out. Oh, went a little crazy on that one. It's all right. Somehow I can't pour today. It's all right. There we go, there we go. That's okay. Let's get a little more here. Let's get a little less there. Let's go. This is really good chemistry right here. Nice steady hand. Little even pouring. Let me set this in here so you can see it. All right, there you go. So as you can see, we're roughly equal. It's close enough. Now I'm going to move this one over here because that's going to stand as our original control. Okay. And then I'm going to make adjustments to each of these tubes to see what goes on. Okay. Now in the very first one, it says, so here's my control tube. And then I'll pull this back so you kind of see it as it goes, but then I'll hold it up to the camera. In one of the test tubes gives 2 drops of mercury nitrate. All right. Here's my mercury nitrate. 2 drops. Bam. Bam. Okay. And I'm going to grab my parafilm here and give it a little something something. Okay. And there goes that one. Okay. One test tube gets a little iron chloride. So let's put a little iron chloride in this one. 1, 2. And again, I got gloves on. I'll just do this. Give it a little mix. Okay. The next test tube, give it a little potassium thiocyanate. And a 1 and a 2. And again, give that a little shake. And if you're kind of looking closely, you can kind of see what's going on here. Okay. And then in the last tube, a little potassium chloride solid. You get an official chemistry term, a little schmibly of, which just means just a little touch, a little schmibly of the potassium chloride. Schmibly away. Okay. And let's get that kind of mixed in. Let me just give a little dump up and down. All right. And then here we can, let me get this as close as we can see. This was our original control. This one you can see right here, if I put it next, okay, was the one that I put the mercury, where am I looking at? The mercury nitrate in. Here was the one that I put some more iron chloride in, so I increased the iron. Here's the one that I put more thiocyanate in. Oops, hold these up. Here's the one that I put a little schmibly, and I'll hold it kind of there. You can see it's not quite clear. It's a light orange, a little schmibly of my sodium chloride in there. Okay. So, and what we said was the mercury nitrate decreased the amount of thiocyanate. Okay. Meaning the mercury bound up with the thiocyanate, so it removed that from the equation. Here we added iron. Here we added thiocyanate. And here again, the chloride came in and bound up some of the iron and really removed some of that iron. And again, this was our initial control. All right. And so when you're looking at these, the question is, as I added these things and they did what they did, which is explained in your lab procedure, you notice that the color shifted. Okay. And what does that mean? You know, what does that mean about which way the stress went? And what does that mean for essentially the amount of reactant or the amount of product? Which way did the equilibrium shift? Okay. You know, and this isn't a one-off and done. I'll take the mercury one, for example. Okay. We added some mercury nitrate, which bound up the thiocyanate. What if I add some thiocyanate back to it? This is not in your procedure, but I'm just going to show you. What if we add even just a drop of thiocyanate back to it? And I give it a little shake. Okay. Well, not a whole lot, but you saw some color there. It just disappeared. But I'm stressing the system again and putting in a couple of drops of thiocyanate. And now you can see it change color again. So I shifted the equilibrium. Now, if I go back again to the mercury nitrate, again, all I'm doing is constantly putting a stress on the system so that reaction can, you know, readjust and reassess. Now I put some mercury nitrate back in, and you notice that the color changes again. Anyhow, there we go. That was our first example of a concentration change with a little extra for you that I decided to do to show you that shifting. I'm going to pause for a second so I can set up the next one. See you shortly. Okay, hey, we're back again briefly. I just wanted to show you this. This is part 2. And all I want to do, I wanted to see this blue color, which is the cobalt chloride mixed with the ethyl alcohol to give you this blue color. We'll be back in a second. Okay, we are back. And we're on part 2, and I've got a setup here. What you can see is I've got a hot bath. This is a temperature one. So I have a hot bath, I have an ice bath, And you saw this, I don't know, you know, I'm wearing a red shirt. So anyhow, let me stand here. So you saw the blue, I mixed up, so this is a cobalt chloride, mix it with a little ethanol, ethyl alcohol, and then you put in some water, and you saw when I mixed it with the ethyl alcohol, it was a dark blue. Add in a little bit of water that then turns it pink, okay? And then this is a temperature one, as you can see by kind of the reaction there, that this is well, it's not a super huge hot exothermic, but it's an exothermic reaction. It releases heat, which is not anything you'd really notice, but at equilibrium, the heat, the energy releases on the product side. Anyhow, so now I'm going to start doing my stressors. And the first stressor is I'm going to put it in heat. So I'm increasing the temperature, increasing the energy on this side on the product side of the reactant. Okay. And what I can see, and I'll start showing you, if you look at it, we're starting to get a little twilight here. As you see on the top, it's getting a little blue. And the pink's going away. It's got a very nice look of twilight. And as I continue to add the heat and it continues stressing and driving the reaction more, then you can see it's getting bluer and bluer. I can see a little pink in there, but the camera doesn't quite do justice to kind of the right at dusk kind of little pinky, little blue hue towards the top, you know. Kind of see that if I put a background on, you can see a little more pink on the bottom. Okay. And there you go. You can see with the heat that we are blue. Let's go to the ice bath and cool it down. Now, essentially, I'm removing heat. I'm reducing the energy. I'm slowing things down. And what do I start seeing? There we go. Oh, look at that. Now it's like sunrise in the morning. Look at that pink coming up from the bottom. Good morning, chemistry. A little more cool water. You can see it's getting more pink as we go. And again, the question you're looking at as we do this data is, how is this affecting the equilibrium? Which way am I gaining product or losing product towards reactants? Which way is it shifting? There we go. Oh, so beautiful in its pinkness. Very little blue left over. So how is that temperature affecting the equilibrium as it settles? And again, reversible reactions will always settle into an equilibrium. It just may not be in the same spot. It may be a different equilibrium. And as we talk about, you can use that in the manufacturing world and in the real world to maybe drive a reaction to get more of the product that you want if its natural equilibrium does not set you where you want to be. Anyhow, we need to pause again. We have one more demonstration lab. If I can get it to pause, we'll be back. Okay, we are back again with our final equilibrium lab example. And this one again is a concentration one, as it was with the first one. But it's not going to be a color change. This one's going to be visual because of a precipitate. So here I have my silver nitrate, and if you follow along, it says I just need 5 drops in the tube. So a 1, 2, 3, 4, 5. Nothing exciting, just clear. Okay. And then I'm going to add in 5 drops of the sodium chloride solution. Again, same concentration. 1, 2, 3, 4, 5. And what you see is it turned a a rather milky white. It looks good against my Badger Go Bucky pullover. Anyhow, what it does is it forms a silver chloride precipitate, a very good chunky silver chloride precipitate. Okay, and again on the reaction there, all we've really shown you are the ions that are controlling, that are involved in the reaction. The sodium and the nitrate really are what are called spectator ions. They just aren't doing much. They just stay in solution. So it's really between the silver, the chlorine, and the silver chloride precipitate. Okay. Our first stressor, now that I'm in equilibrium, is which? Oh, to grab some ammonia and drop in some ammonia. Okay. And see what happens with the ammonia. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. And I'm going to give it the knuckle. And my precipitate essentially has disappeared. We are back to clear. Okay. All right. So that was the ammonia. If the precipitate, yeah. Okay. So that gets rid of our precipitate. So then ask yourself, which way is that driving the equilibrium? Towards product, towards reactant. What am I gaining more of? My next then deal is to add nitric acid. Okay. So let's do that. Let's add some nitric acid. And you can already see what's going on. And what's happening here is the nitric acid is binding up the ammonia. It's an acid and base. It's neutralizing the ammonia. Okay. Where the ammonia had been binding up the silver. And pulling the silver out of the solution. Okay. This gets rid of the ammonia. Okay. And again, let's go above and beyond. Let's add some ammonia back in. It's not part of the procedure, but let's do it. Let's go back with some ammonia. Give it the knuckle. And what do we see going on? Well, it's hard for you to see here, but you can see it is getting lighter. Precipitate is disappearing. As I give it the knuckle, bam, there you go. If I gave it more acid, I'd get my precipitate back. Okay, so there you go. That is the procedure for this lab, and showing LeChatelier's principle and how you can alter a reversible reaction and drive it in different directions based on how you apply the stress so that it settles back down into a new equilibrium. We will tomorrow talk about the analysis for this lab, which is really just the application of the principle in different methods of what we have done. But that's it for lab today. Hope you enjoyed it. Stay healthy, stay safe, and we will talk to you soon.